Okay, the floor is yours, Vladimir.
Okay, thank you very much. Good morning, ladies and gentlemen, colleagues. My name is Vladimir Gumilar. I'm coming from Construction Cluster of Slovenia, a partner of the LIFE HEATLAND project. And I will say a few words at the beginning of this workshop, which is titled "Preparing Our Cities for Climate Challenges and Improving the Quality of Life." I think it says a lot on the content, and actually we have to do it. It's the fact that urbanization is taking place. 2/3 of population already lives in cities, and more will get to the cities. And life, they say living standards are better in cities than outside. I don't believe that so much anymore. I will start with my story to how I see that. But as this is not a big group, I would invite you to present yourself, to see who is today with us, where he or she is coming from, and which company is represented by this FD. So I think the presenters, the lecturers, will present them at the beginning of the lecture. So I would invite other attendees to present. You can open the video and the mic to see just a couple of words. Can you start? I will ask you as I see you on my board. So Manuel, are you there?
Hello.
Hello.
Hello, everyone. My name is Manuel Valls from Murcia City Council. And well, we are here because we are the pilot city that we have implemented this new cool pavement. And the reason we are here in this workshop.
Okay, thank you. Daphne. I hope I spell it correctly.
Hi, my name is Daphne. I am
okay.
from the Aristotle University of Thessaloniki. I'm doing my PhD in biometeorology, and I'm a colleague of Dr. Stavros Kepas. We are both working in a LIFE HEATLAND project that will be presented today.
Thank you. Lorena, CityCon.
Yeah, hello everybody. I'm Lorena, and I work with Fran Modal, that he's presenting LIFE HEATLAND. So we are coordinating the project. So let's see how it's going.
Okay, thank you. Julia. Julia, City of Paris Life Cool and Low Noise Asphalt Project. It's written in chat. Thank you. Alexandra.
Yes, good morning. Did you hear me?
Yes.
Yes, good morning. I'm Alexandra. I am a researcher in the BRC. It's the Belgian Research Road Center in Belgium. And I have a great interest in the call-out coding.
Okay, thank you. And Lorena Palomo.
Yes, she has problems with the micro, and she asked me to present her.
Okay.
She is the responsible for the LIFE HEATLAND project at the CHM construction company.
Okay.
In Spain. She is listening to us, but she can speak.
She cannot speak. Okay. Okay, thank you very much for this. So as I said, I will present my story. I moved to village outside Ljubljana, actually outside a small city near Ljubljana, and I experienced the change because before I was living close to the biggest shopping area in Ljubljana in Slovenia, and actually this was monitored as heat island in Ljubljana beside the city center, and I know the difference. So this is one of the best, I think, solutions to mitigate the heat island effect. But of course, not all the people can do that. Normally they have to stay in the city, and they move to cities, and with the population growing and urbanization taking place, I think the problems are rising, and the climate change also bring or make revenges to us, as we all experienced in these last years. So I think it's very important that we address that. And today we have a really nice opportunity to see from three perspectives how to do that. First is the payments, which will be presented by Francesco Moral from CityCon. The second, this is LIFE project, and the next LIFE project is just a second. Is ASTI, and here it is interesting for me that they deal with the forecasting. I think this is very important, because we cannot base our planning on all data. We have to think in the future how it will be and how we will design our cities to improve our living condition there. And the third one is about roofs, which is also an important surface area in the cities, which can be exploited in different way. And this will be presented within the LIFE project, Urban Roof. So not to say much more, I would invite Francesco to present the outcomes of our project, Heatland. And I would like to invite him to present also, I hope, that this will be presented, that is the outcomes of interviews with the users. I think this social perspective is very important. And there was some as I'm partner of the project, I know that there were some good results and a little bit surprising results in this field. So, Fran, go ahead.
Can you see that?
Yes.
Okay. Well, hello everyone. Hello for coming today with us. My name is Francisco Moral, and I am the head of the Energy and Insulation area at the Construction Technology Center, which is located in Región de Murcia in the southeast of Spain. I'm here because we are the coordinators of this beautiful project that I'm going to present. But at first, sorry, well, it is well known that temperature is getting higher and higher due to many facts, such as the anthropogenic heat, dark surfaces, or heat from machines, among others. And temperature in the city is up to 4 degrees higher than the output, and that is called the urban heat island effect. We can solve it through several ways. Increases our shadows in the city. Best if we do it with vegetation. We can implement green roofs or cool roofs, or our particular case, cool pavement. Almost 40% of the surfaces in cities correspond to traditional pavement. And this pavement absorbs 90% of the incident solar energy, and their surface reaches close to 70 degrees. In previous researches, CHM Construction Company and CityCon developed together a new pavement whose thermal performance was much better, as you can see. This is the new cool pavement, as it is known, and as you can see in the graph, the cool pavement, the green line, absorbs less energy than the traditional one and reaches less temperature than the traditional. And that is how the idea of the LIFE HEATLAND project came up, to demonstrate in real conditions its advantages. And the partners started working together. The partners are the Construction Technology Center, CHM Construction Company, the Regional Federation of Entrepreneurs of Murcia, and the Cluster of Construction of Slovenia. Our goals were mitigate the urban heat island effect, reducing the surface and ambient temperature, contribute to a better quality of life and people's well-being, that we'll talk about it later, achieve energy savings in the urban environment, reduce air pollution, and develop a tool to assess the impact of the implementation of this new pavement in any city. Now we are going to watch a video to see the implementation works.
LIFE HEATLAND project, innovative pavement for mitigation of urban heat island effect. Project co-founded by the LIFE program of the European Union. After a year monitoring parameters such as surface temperature or solar radiation, LIFE HEATLAND project reached the most important milestone in February 2020, the implementation of reflective pavement. This innovative cold pavement has been manufactured in the facilities of the construction company CHM, which has redesigned the plant to adapt the characteristics of the new mixture. This mixture does not use the traditional black bitumen derived from petroleum, but a colorless synthetic binder which has been obtained from a mixture of high molecular weight organic components. The process followed to carry out the implementation is as follows: milling the existing pavement, adding emulsion to ensure intercoat adhesion, implementation of the mixture, compaction of the mixture, painting to replace the road markings, quality control tests such as slip resistant tests and thermography were carried out. Works have been carried out on an area of 24,000 square meters, comprising a total of 7 streets, 6 paved with the innovative cool asphalt, and 1 paved with a traditional one in order to be able to compare measured data. At the moment, the visual results after the works is spectacular. The 2 aspects that most attract their attention are the reduction of noise and the good night lighting.
Yes.
Li-
Yes. Yeah. We can talk now about the social part of the project before talking about the our technical result. You have seen in the video, people feel safer than before because of the increase of the luminance, and also because of the reduction of the surface temperature. They can walk with their pets through the street without any problem, and also they feel more comfortable while driving because of the reduction of the vibration inside the car. Okay. Here we have the map. We have generated 6.5 million data until now. We have 4 measurement towers, as you can see, and we measure more or less 25 parameters, such as surface temperature, ambient temperature, humidity, carbon dioxide, noise.
Στείλατε στην περιφέρεια το
The
κείμενο.
micro is open.
Ωραία, τέλεια. Ναι, μια που είπατε
Daphne,
για το Δήμο
please
Θεσσαλονίκης, μήπως να κάνουμε
mute
ένα
your
letter for
microphone.
understanding ή οτιδήποτε τέτοιο. Μήπως πρέπει να κάνουμε κάτι αντίστοιχο και με
Daphne.
τη Φραντσέσκα, τη Δάση.
Well, I think I can follow. Okay, and here we have a couple of pictures of this new cool pavement from the roof of the building.
Θα χρειαστεί
Yeah,
σίγουρα σαν stakeholder που είναι ήδη, ενδιαφέρεται ήδη. Γιατί αυτό γράφω τώρα.
Well, I continue. Well, but no. However, I have to tell you something. The base stone has evolved over time to a white stone that, due to air pollution and the particles that are in the environment, results in a gray stone. However hard we try, it is impossible to eliminate this phenomenon. Long story short, this happens in the same way to the traditional pavement, but nobody notices because it's black. Okay. In spite of this, the energy and light properties are hardly affected. And also the passage of vehicles and the rain, as you can see in the picture of the 120, contribute to clean the pavement. Okay. We have also developed a business intelligence tool in order to properly analyze our data, because Excel, as you know, was overwhelmed with such a huge quantity of data. Now, let's talk our technical results. First, luminance has been increased initially by 150%, and you can see the picture, and now the value of the increase is 100%. And you can see the picture that the lightning of the cars while driving is higher than with the black. Okay. Solar reflectance is now 170% higher than the conventional paper. But what about surface temperature? It has been decreased between 7 and 11 degrees. Here you can see a thermography from 86. It is in the most unfavorable condition because it is the interface between the traditional and the cool pavement. So it's a heat exchange between them. And now another thermography in another location that day, you can see 7 degrees of mean difference, and the maximum difference in temperature is 10 degrees. So we can say the general performance of this cool pavement, even if it gets darker, okay, the surface temperature decreases between 7 and 11 degrees with a maximum peak of 15 degrees. Well, here in this picture, you can see the difference in temperature between the areas of the clean cool pavement, dark cool pavement, and the traditional one. You can see we can reach up to 13 degrees for June the 14th last year. In order to spread and replicate our technology, we have developed an app, a tool, which is with the mathematical model we have developed, and it has been validated with our experimental data that we have collected from the measurement towers, and also with meteorological data that is outside the project implementation area. Okay, and here you can see example of prediction of the change of the traditional pavement for the cool pavement. Okay. And finally, noise has been decreased by 3 dBAs. As you can see, even you can notice the huge reduction during the strict lockdown that we suffered last year. And here I have the recording. I hope you listen it well. The noise for the traditional pavement while driving, and the noise in the full pavement. Okay, I think you are able to notice the difference. It's 3 dBAs less, which is more than less the 15% less of the traffic in that area. And finally, this is our summary of results. And just the last slide, we have organized one more workshop next November the 17th. And the cities of Phoenix and Los Angeles will take part, and they will talk about their program reducing the urban heat islands, and they are the original thinkers of this idea that we were talking about before creating our project. So it's a huge success that they will take part in the next course. And here you have our social media that you can follow. Yes, and that's all. You are muted, Vladimir.
Vladimir, you don't have the microphone turned on.
Yeah.
Yeah.
Sorry. Thank you very much, friend. Somebody can read from my lips what I'm saying. That's good. Normal problem. You can ask questions, Fran and other partners of the team from CityCon, if you have some. Go ahead,
actually,
Carlos.
I have one. Yeah, it's actually very interesting work, and I would like to ask, is there any report that refers to the specifications of the cool materials that you suggest? I mean, in terms of albedo or emissivity. So do we have any specific numbers? How much the albedo or the emissivity would improve using, for example, a cool asphalt?
Yes, I have the the numbers here. Yes, solar reflectance is 24% after a year in the cool pavement, and the conventional one is 80%, and that is why it's 170% more with our full pavement. After a year, initially it was 70% the solar reflectance, but after a year, as I have said, the darkening of this asphalt, but it maintains their properties. 24% the solar reflectance. And the emissivity, I don't have the value here, but I remember it is the same. That,
okay,
I mean, I'm not sure. I know the.
No problem with that. Actually, I think that there could be a synergy between Life and Heatlands, because we make some sensitivity tests in albedo and emissivity in order to see the impact of these changes in the urban microclimate. So it would be nice if you could share with me such results. If you have any publication, or if there is something in a report of your program, something like that.
Yes, we haven't published anything in the scientific research, because we are writing the article, but we can send you the results that we can share that are in our report.
Okay.
To do that study that you are.
Mm-hmm. Thank you very much. I'm writing my email in chat, so please, when you have time, just send me any files that you have.
Okay.
Thank you very much.
Thank you, Stavros. Some more questions? Don't be shy. Be concrete. If not, I have one actually to tell a few words about improving these figures with the cleaning. How was that going on? What was the experience in this regard?
Yes, we did several experiences regarding the cleaning of the asphalt, and I don't have the video here because I have 2 or 3 videos during the cleaning. And when you clean with pressure water, okay, the original color is under this dark layer of particles and air pollution. Okay, so the original asphalt is under this layer, but you know, we don't have much water here in Murcia, and due to the fact that the thermal properties are hardly affected, we consider it is not necessary to waste money, time, and water in cleaning, because the lighting at night is better than the previous situation, and all the properties remain more or less in the same value. So it is not necessary to clean. And even it's better because if you change only the streets that are a problem in our cities, for example, a big avenue or a street for pedestrians, okay, if it turns into a gray stone after several months, you cannot notice the difference visually, and you are not going to have a colored city. In one street gray, black, one street gray, and one street beige. Now you have a city in the same color, in the black, gray tone. So I think it is good for us to turn to a gray tone because of it.
Okay, maybe one more question from my side. I presented this project in a meeting of Interreg project dealing with public procurement of innovation. This is quite supported by EU Commission, that municipality and public bodies actually go for better, more innovative and novel solutions to reach their goals in terms of climate change or other needs of the municipalities. And from my knowledge, this asphalt, this pavement goes into this field of innovative solutions because there is no offer on the market. It's not traditional one, it's different. And what do you think, how this can be exploited in other cities beside Murcia, where you have Murcia City Council among the project members? How you or CHM, how they will deal with that to be able to provide that solution to other cities in Spain, or in our case also in some other countries in Europe?
Well, first of all, I haven't mentioned before that the mechanical properties of this new pavement are the same or even better results than the traditional ones. So in terms of mechanical properties, it doesn't matter if you implement the traditional or the full pavement. So how can we do that? Well, we have to disseminate our technology to convince people, not only municipalities, but also the private promoting companies that do the urban development of our cities. And Lorena can talk right now because she has a problem with the micro. But well, they are reaching some deals with our partners to spread this technology. But I can tell you more. Sorry, Lorena.
So there is, in regards some technical specification for payments, there is no like barriers that this payment can be going for some public tender of municipalities for payments. So there is no part of any technical specification which are there in Spain, which might prevent this to go and be a potential offer.
Yes, well, they can write in the public procurement a specific requirement regarding the albedo, the solar protectance. If the pavement you need to implement is needed solar reflectance that more or less 20%, then the only way is with this full technology.
Okay, so this is
the requirement in the public.
So I think this is a process or a case study which should be somewhere done, to see, yes, we can order that kind of payment, and it's possible, and it's also economically feasible. That's also one important thing, long term. And another question about the let's say maintainability and let's say durability of this material. Can you say a couple of words about that durability compared to traditional asphalt?
Yes, as I have said before, the same or even better. We estimate that this asphalt could last 5 more years, but it's not sure because we need to see how here in Murcia it performs. But regarding the mechanical properties and all our studies, the lifetime of this mixture, asphalt mixture, this pavement is the same.
Okay, perfect. Thank you. Any other question? If not, we will go on with the next presentation. So, who is next in the line? I think Stavros, it's your turn, and you can share the screen. You're doing that, so go ahead.
Okay, yeah. So, hi all. My name is Stavros Kepos, and I am a research associate in the Laboratory of Atmospheric Physics in the School of Physics in the Aristotle University of Thessaloniki, and I'm going to give you a general overview of the project LIFE ASTI, which focuses on the investigation of the urban weather and climate in the cities of Thessaloniki and Rome, and on the development of tools and adaptation strategies in order to combat the urban heat island effect. First, I would like to thank you for inviting us to participate in this workshop, as it is always interesting to see and compare the work of relevant LIFE projects together. So, give me a moment. Okay, so let's start with the presentation, getting firstly an overview of it. In this short presentation, we will say a few words about the urbanization and the effects of urban heat island, and then we will focus on the Life HASTI, the goals of the project, and the showing of a sample of results arose from our research. So urbanization is an effect of the modern world, and it seems that it is a rapidly evolving effect. As an illustration, our world has significantly changed from 1950 to the present. And in this figure, you may see that in 50s, there were just a few large cities or megacities across the world with a population of 750,000 inhabitants or larger, something that has dramatically changed till the present. Giving some numbers, it seems that only 30% of the Earth's population lived in cities in 1950, a percentage that increased to 55% in 2018, and it is expected to grow further to almost 70% until 2050. We should also point out that this population has already reached 70 to 80% in America and Europe. Okay, so urbanization is an effect that triggers another effect, which is called urban heat island. The urban heat island effect is practically the temperature difference between an urban area and the surroundings, and it is caused by the materials that the cities are made of and the human activities. Here you may see the quite simple formula that calculates the urban heat island, which is actually the subtraction of the two temperatures in and out of the city and out of the city. And so let's have a look at some schemes and figures to understand the generic characteristics of this effect. As the land of the cities is covered by a lot of concrete, that means that there are generally less green areas, which then means that during the day, cities absorb more heat, and due to the properties of the materials, this heat is stored and preserved for longer time. This is the main reason that urban heat island is observed mainly during the night, as you can see in the blue solid line in the graph that was shown previously as well, which actually shows that the typical surface temperature is higher in a city compared to its surroundings under calm conditions. So as I said, and as we can see in the orange dust line, the temperature remains almost similar in and out the city during the day. However, it cannot drop that much in the urban area during the night, which may be really stressful for the urban inhabitants, especially during a prolonged warm period, for example. Additional factors which add extra stress in the cities are the lack of the evapotranspiration due to the lack of green areas, while a significant role is played by the activities of the inhabitants, such as the transportation and the energy consumption for cooling purposes during summer. So, is urban heat island an effect that we should find ways to eliminate? Is it worth to do it? The answer is definitely yes. In order to convince ourselves or to make this statement slightly stronger, let's have a look at some statistics. During the period 1998 to 2017, so actually during the last 2 decades, more than 166,000 people died because they were exposed to extreme temperatures. One of the examples during this period is the extreme heat wave of 2003 in Europe, when 70,000 people died due to that prolonged heat wave, while another prolonged heat wave in Russia in 2010 was responsible for the death of 56,000 people. In general, we could say that the last 20 years, the number of the people exposed to heat waves increased by 125 million, which definitely is a non-negligible number. So heat waves affect public health. There are various groups of people being in risk during heat waves, which, as we discussed, are enhanced within urban areas. These may be vulnerable groups, less able people, pregnant, homeless, children and elder people, athletes, and outdoor workers. So we definitely talk about a significant part of the population. Mostly in these groups, heat waves may lead to or enhance pre-existing cardiovascular and respiratory disorders. In the next two graphs, we may see two different aspects of heat waves in an already degraded environment, such as a large city. On the left, we can see in a quantitative way that the morbidity and mortality risk increase at cold conditions, but they mostly increase at daily mean temperatures larger than 28 to 30 degrees Celsius. Regarding the power consumption, the right graph shows the average electric load as a function of maximum daily temperature in the city of New Orleans, which is a large city with warm and wet climate. We can clearly see that the electric load is practically doubled for maximum daily temperatures at 38 degrees Celsius, comparing to maximum temperatures of around 20 degrees Celsius, which is considered as a comfort zone for people. Now let's move to the LIFE HEATLAND project, mentioning firstly some general information. So this project is conducted under the collaboration of institutions of Greece and Italy, or specifically of Thessaloniki and Rome, and the entire work is applied to the cities of Thessaloniki and Rome, worth to say that the work is replicated to the city of Heraklion in Crete. And actually, the replication to other cities of the forecasting system developed under LIFE HEATLAND is one of our final goals. We want this system and this program, the result of this program, the product of this program, to be replicated to other cities as well. The coordinator of the project is the Aristotle University of Thessaloniki, and the duration of the program is 3 years in total, having begun in September 2018. So we've got a small extension to finalize our work now. So let's have a look at the goals of this project. One of the most important goals is to effectively inform and equip the community against the extreme weather, mostly in terms of temperature, in order to be well prepared. So firstly, we aim to, and we have created a reliable weather forecasting system, which efficiently simulates variables such as temperature and humidity, which are the basis for the purposes of this project. Then all this information needs to be accessible by everyone, so everyone can be advised for their activities. For this purpose, a toolkit has been developed which provides daily forecasts of different parameters for the next 4 days for the cities of Rome, Thessaloniki, and Heraklion. Of course, this is a tool that can be used by local policymakers in order to establish emergency plans. And finally, we make people be aware of this effect and our results through seminars, events, some workshops, etc. It is really important that people know and do not ignore something that today looks like just an occasional problem, but in the next decades could potentially be a permanent problem. And talking about the tool, here you can see some screenshots of the tool for the two cities. The same forecasts are produced for Heraklion as well. As I said before, the original resolution of the model and the product that the visitor experiences today on the website is of 2 kilometers. However, we work on a statistical downscale algorithm in order to increase the resolution to 250 meters over the urban areas. Having such a high resolution of 250 meters, we will actually have a heat health warning system, but this will also allow us to better understand the role and the impact of green areas in the cities, and of course to suggest more targeted strategies to the local administration. Regarding the app, the user can have access to interactive maps of basic and special meteorological variables, while there is an alert system when weather is expected to be very hot and could affect public health. This system is based on the apparent temperature, which is an index based, based on temperature and dew point. Actually, here the apparent temperature has been correlated with mortality risk, as you can see in the graph in the graph appeared right now. So one of the actions, and in fact another goal of the LIFE HEATLAND project, is to assess the impact of the climate change on the microclimate of the cities and the urban heat island effect. For such purposes, future simulations have been conducted for these domains, and we will see in the next slides some results. But also we plan, as I said previously, sensitivity studies changing albedo and emissivity of urban surfaces to see if the proposed adaptation and mitigation strategies will have an actual impact on each of the cities. Based on that, we will be able to contribute to a guidebook that will be used for combating the urban heat island effect. Finally, and before we move to the discussion of some results, I would like to highlight the importance of the replicability and transferability of this project. So the tool and the model that has been developed can be applied to other urban areas experiencing an intense urban heat island effect. In addition, we also produce in an operational basis forecasts for the central and eastern Mediterranean with a coarser resolution of 6 kilometers, which potentially can allow us to identify other cities in this domain that present similar issues. And of course, as I earlier mentioned, we aim to a practice guidebook which will indicate the means, policies, and financial tools for increasing resilience to heat beyond the cities of this program. So, of course, by all means, we aim to the replication of this program to other cities as well, as I said. In the next slides, we will discuss some results arose from our work. As previously mentioned, one of our goals is to see how the climate change will affect the urban microclimate of these two cities. Here you can see the setup of the model we use, which is same to this of the operational model that we run in an operational basis, in a daily basis. The only change between these two models is in the resolution of the larger domains due to the different resolution of the initial data. We used the worst, this is something that I would really highlight, is that we used the worst case emission scenarios, the so-called RCP 8.5, and we simulated three periods. The one which we refer to as the reference period, and it is the 2006-2010, and two future periods for the middle and the end of the 21st century. And here it is actually the RCP 8.5 emission scenario depicted with the red line, which shows a continuous increase of the emissions and an estimated increase of the global average temperature of around 5 degrees Celsius by 2100. So this is actually the scenario under which we do not make any efforts at all to decrease the emissions. So in this slide, we can have a general look of the average summer minimum and maximum temperatures of the current and future climate along an axis that passes through urban and non-urban areas in Thessaloniki and Rome. You may see these axes with red lines in the maps of Thessaloniki and Rome. So let's explain a bit more the graphs. With dot line, we see maximum temperatures, while with solid lines, we see minimum temperatures. Pink is for current climate, red for the middle of the century, and dark red for the end of the century. We also added a color line at the bottom indicating the land use. So we represent urban fabric with gray color. As you can note, in both cities, the urban heat island effect is obviously early in the morning, when the minimum temperature is higher by 2 to 3 degrees Celsius comparing to the non-urban surrounding areas. What we also notice is that maximum temperatures are not affected by the land use significantly. In contrast, we may see some subtle drop by up to around 1 degree Celsius in maximum temperature over the cities, but this may be due to other factors such as topography, for example. Finally, taking into account that the city remains in terms of size, shape, and land use as it is today, we don't expect any changes in the pattern of the urban heat island effect till 2100. However, the average summer temperature increases by around 4 degrees Celsius, which means that by 2100, the urban areas of Rome and Thessaloniki may present an average minimum temperature of 27 and 29 degrees Celsius, respectively, which actually adds a lot of extra heat stress in both cities. And indicatively, I chose to show you some maps of the variable of apparent temperature, which is an index based on temperature and dew point, as you see at the top of this slide. So indirectly, this index is correlated with humidity, and it is an index for expressing the discomfort that people feel. All of the maps refer to the average values of the index at 3 UTC in summer, so early in the morning. The upper maps are for Thessaloniki and the maps at the bottom for Rome. The maps at the left show the current situation, and the other maps show the increases we expect until 2050 and 2100 respectively in the variable of apparent temperature. In the current climate, it seems that the apparent temperature is higher in an average summer morning in both cities of Thessaloniki and Rome by around 4 and 3 degrees Celsius respectively. Considering that there will be no changes in the structure of the cities in the future, in the worst case scenario, the city of Rome will experience increases of larger than 2.5 and 5.5 degrees Celsius by 2050 and 2100 respectively. And actually, this increase seems to be higher by 0.5 degrees Celsius comparing to some surrounding areas. For the city of Thessaloniki, apparent temperature will increase by 2.3 and 4.7 degrees Celsius. An increase will be which will be lower by half or 1 degree Celsius comparing to other surrounding areas. However, the apparent temperature will still be higher than other rural areas, and actually much higher than today, adding, as I said before, a significant heat stress to the citizens of the city, which is already experiencing fairly hot summers. In the next graph, we distinguish areas regarding their land use. So we have urban with bold colors and non-urban with lighter colors. And then we categorize them to coastal, non-coastal, low level, and elevated areas over located at altitudes larger than 100 meters. And you can see them with blue, green, and brown shades in both the maps and the graphs. So what we actually noticed here is that days with minimum temperatures larger than 20 degrees Celsius through the year, so which are referred to as tropical nights in the peer-reviewed literature, will mostly increase over coastal areas. And actually, this increase is much more intense in coastal urban areas, as today the number of such days is around 80 per year. So almost around is around 3 months, but until 2100 it will be around 7 months within a year. However, non-urban coastal areas will present only 4 months in total of days with such characteristics through the year. The other two classes exhibit, as you can see, a similar increase for both urban and non-urban areas, regardless the land use, reaching at the end of the century the duration of around 4 months. In the next graph, what we see is actually the expected changes of urban heat island effects in the future under no changes in the urban fabric traits in both cities. Again, we have categorized the regions into coastal, low ground, and elevated ones. In general, we see that the urban heat island intensity changes in a significant way between a range of in an insignificant way between a range of plus or minus 0.2 degrees Celsius. The largest increase would be expected in the coastal areas of the Thessaloniki. So by 2100, the urban coastal areas may be warmer than non-urban coastal areas by 0.2 degrees Celsius in the afternoon, which again is really insignificant, to be honest. It is interesting, though, that urban heat island intensity tends to decrease in the future early in the morning, which may be due to the presence of the sea next to the city of Thessaloniki. However, this is something that should be further investigated. On the other hand, in Rome, we see that the graphs are fairly flat, not showing any significant trends at all regarding the urban heat island intensity change in the future. In this slide here, we can see some results for Thessaloniki as they presented and published at the EnviroRisks conference the last autumn, the autumn last year, from the dataset produced through the future simulations. We chose these days with maximum temperatures equal to or larger than 37 degrees Celsius and daily temperature larger than or equal to 31 degrees Celsius, which we call heat wave days. Then we compared an urban and a non-urban point of Thessaloniki. We can see that the number of heat wave days will increase from 4 and 13 for the entire period of 2006-2010 to 66 and 161 by 2100. We can also see in the second graph the discomfort index, which is an index that includes both temperature and humidity in order to estimate the heat stress that people feel. What we can clearly see is that the average minimum discomfort index during the heat wave days will increase until the end of the century to levels of larger than 50% of the population that typically feels discomfort. And this is exceptionally important if we consider that the majority of people need to feel comfortable during the night when they rest. Finally, we also see in the left graph here that minimum temperature will be exceeding 30 degrees Celsius in 63% of the heat wave days in the urban area of Thessaloniki by 2100. Such days are only the 8% of the heat wave days today. Respectively, in the rural area of Mechaniona, this percentage will be just 20% by the end of the century. So we can see that the urban area will experience a much larger stress, especially during the night and early in the morning. So concluding, urban heat island effect can additionally increase the average temperature of a city by 1 to 3 degrees Celsius. And actually this increase is added on the global warming effect. The urban heat island is an effect that should make us concerned about, as it affects more than half of the global population. This effect has been correlated with the number of deaths due to cardiovascular and respiratory disorders, and obviously a heat-stressed environment where a large population lives demands higher energy due to massive usage of air conditioning system, especially during the night when people typically rest. Taking into account that cities around the Mediterranean are already experiencing fairly hot summers, this condition is expected to get worse in the future. And finally, this will have more significant impacts on public health. So what we can actually do is to apply some adaptation strategies within large cities in order to restore the land use into something more natural and less artificial, let's say. This could decrease the average temperature of the cities and also reduce the amount of the energy that consumed, which then will have a small impact on the greenhouse gas emissions as well. And actually, this is one of the last steps in life fasting. So we are making some sensitivity tests, changing land use within the urban fabric in order to plan a certain strategy to upgrade the environment of the cities. So we want actually to see if the application of green roofs or cool pavements will have a certain and significant impact to the microclimate of the cities. This is something that we are doing right now, so we don't have any results to show for now. And so we aim to further publications, of course, focusing on heat health risk assessment and the effect of urban adaptation strategies on the urban microclimate in the next months. So stay tuned. I would kindly ask you to follow LifeFasty on Facebook, YouTube, Instagram, and LinkedIn, while you're more than welcome to visit our website, lifefasty.eu, and be advised by our operationally produced forecasts in Thessaloniki, Rome, and Heraklion. Thank you for your attention.
Thank you very much, Stavros. It was a great presentation and great work done.
Thank you.
For sure. We are all worried about 2100. Okay, luckily I will not be there anymore, but I think we should think on our our successors, sons, daughters, and their sons and daughters.
Sure.
So I think it's really important to work on that. And I have some questions, but firstly, let's ask the others if they have to comment. They can comment, they can add something, or ask Stavros anything in regard to that studies. Please go ahead, open the mic and just make a question.
Well, me again. Yes. No, I just want to say that as you have said before, we can collaborate to see if we can improve your tool with the cool technology in order to see if in 2100 we can have better results with this technology. Maybe it's a good idea to to spread the full pavement technology if people is aware of this issue. It's very, very dangerous for us. And that's all. It was a very interesting presentation.
Okay. Yeah, I think that it is really important to plan strategies right now, because we all know that, especially in some countries, this construction, this infrastructure takes time to be applied, and so yeah. Of course, if we don't make it now, at some point it may be too late. I mean, we need to prevent any deaths that or any public health issues before they take place. Certainly.
Yes, that's for sure. We are now responsible for our future and for our grandson future, or in my case, my sons. I'm a little younger.
So yeah, we could stay in contact in order to see if there are any synergies and any collaboration. Yeah, great. Thank you.
Okay, perfect. Thank you. Any other question or comment? Okay, if not, I have some question or something to discuss about. We need, as you said, already plan the future, and actually, this kind of outcomes and data need to be, let's say, standardized or in standard way provided to all planners and designers of buildings and infrastructure. So how to deal with that? You know, how to deal with processes which are behind the planning, you know, and the data they use in their desks to plan the energy efficiency, the particularities of buildings and the surroundings and the pavements, the streets, the green surfaces, how to combat actually the business part of these investments, which wants more living, working space on less surface area, less land space, because of the price of the real estate in all cities. So, you know, this is what drives actually the neighborhoods, which are, I can say, in Slovenia much different than they used to be in the past. Where I lived, actually, the old neighborhood of apartment blocks is really in green area, you know, and the percentage of green area around those blocks is huge. But on the other hand, or the other side, we had this shopping mall with metal roofs on that. So, you know, how to move this data to heads of the planners and designers, and not only in heads but in hands. You know, they have to take that into account to avoid, to mitigate, to get ready, to prevent actually deaths.
So yeah, so first of all, I would say that we need to the sensitivity tests that we will conduct have exactly this role. So we will apply various scenarios of emissivity and albedo, which means that we will see which of these scenarios will have some significant impact on the temperature, for example. And then we will see this scenario, how this scenario would be would take place in a city. I mean, then we need to find all the materials that should be used in order to have this this result. Firstly, in terms of albedo and emissivity, and then in terms of temperature and humidity. So yeah, definitely is really challenging. How to reform a city into a green area, this is really challenging. Of course, we cannot demolish any buildings, but you can reform these buildings. You can renovate these buildings, making some green roofs, making a city appear like a natural, semi-natural area. But yeah, of course, this takes time. It's not something that we can do right now. And the other thing is that it's not easy to convince people. I mean, blocks of apartments to take the decision and spend some money in order to make a green roof. So yeah, definitely is really challenging, and we want to see if it is worth to convert our cities to this model, to a green model, and see how it goes.
Okay, thank you. I think in the next presentation we will see how this can be done in regard to green roofs. So I would invite Mr. Giannis Lamesios, Giannis, to go ahead with showing us how that can be done in your case studies.
I think, yeah, that you can see my screen and presentation. Yes.
Yes.
Okay. So hello, my name is Giannis Lemesios. I'm a research associate at the National Observatory of Athens, and I'm going to present you an outcome of our LIFE project, the Urban Proof, which is the Urban Proof Toolkit. It's a decision support tool for climate proofing urban municipalities. Some introductory words about the LIFE project. As you can see, the areas of implementations were Cyprus, Greece, and Italy. You can see also the budget. The duration was 55 months. It started on October of 2016 and ended at April of 2021. You can see also for the website, the link of the website of the project for more information. The overall aim of the Urban Proof project is to increase the resilience of municipalities to climate change, equipping them with a powerful tool for supporting better informed decision-making on climate change adaptation planning. The coordinator of the Urban Proof project was the Department of Environment of the Ministry of Agriculture, Rural Development and Environment of Cyprus. Participated also 3 research institutes, the National Technical University of Athens, the National Observatory of Athens, the University of Venice, and also participated 4 municipalities, the Strovolos municipality and La Catania municipality from Cyprus, the municipality of Peristeri from Greece, and the municipality of Reggio Emilia of Italy. The main actions of the project was the simulation of the current climate and projection of future changes in climate, climate change impact and adaptation assessment, development of the Urban Proof Toolkit and for supporting better informed decision making, the implementation of selected green and soft adaptation measures, and finally, the development of the local climate change adaptation strategies. Now for the urban-proof toolkit. It consists of 5 independent stages, which altogether constitute the adaptation process. As you can see, the stage 1 provides information about climate change, the stage 2 about the impact assessment, the stage 3 is exploitation and evaluation of adaptation options, the 4th stage is the development of the adaptation strategy, and final, the stage 5 is the monitoring and the review of the adaptation measure. The urban-proof toolkit may support municipalities in the development of their climate action plans, for example, in the framework of the governance of mayors. The applicability now of the toolkit, it may be used for conducting an impact and adaptation assessment for every urban municipality of Italy, Greece, and Cyprus. And the urban-proof municipalities include all local administrative units, level 2, the LAO 2, as called, which are classified as the cities, densely populated area, towns and suburbs in the mediate density areas. So, urban-proof toolkit may be used by 2,807 municipalities in Italy, 129 municipalities in Greece, and 62 municipalities in Cyprus. You can see here in this, all the urban municipalities, the LAO 2 urban municipalities in Italy, Greece, and Cyprus. The methodology now used for the impact assessment was based on the relevant conceptual framework presented within the 5th assessment report of the IPCC. In this methodology, the impacts are considered to result from the interaction of hazard and vulnerability, while the vulnerability is considered to be a function of the exposure, sensitivity, and adaptive capacity of the population and the infrastructure. So, for the impact assessment, to assess all these different hazard, vulnerability, and other indicators, we used more specific indicators. So, to assessment hazard, we used different climatic indicators. For the exposure indicators, we used population, land, and critical infrastructure to an impact indicator. For the sensitivity, we use indicators about population groups which are considered sensitive to climate change. And for the adaptation, we used indicator about the capacity of the healthcare system and of the economy to address the climate change impacts. Now for the assessing the climate change impact, we use a composite indicator approach, as composite indices capture the multidimensionality of impacts in a comprehensible form, and therefore may support practical decision-making processes. All indicators were normalized by applying the min-max method, while the 5-class system was then applied representing values from high to low. You can see also in the table on the right, the quantitative scale as well as the numerical scale we used for the normalization of all the indicators. I have to mention here that the results of the impact assessment may provide an indication of the intensity of impact expected and for the areas that will be mostly affected. More details, field research, and consultation with stakeholders are necessary in order to determine what is needed for adaptation planning. For the climatic now indicators, we used 2 scenarios for the future projections. We used the RCP 4.5, which a normalized, let's say, emission scenario, and also the extreme scenario RCP 8.5, which is the so-called baseline scenario that does not include any specific climate mitigation target. We also used the period 1971 to 2000 for the reference period, with a future projection for the period 2031 and 2060. For the social vulnerability index, we used many different social vulnerability indicators, and we combine all of them to compose the social vulnerability index. As you can see, we use different social vulnerability indexes: the elderly people, the very young children, the illiterate, population with chronic diseases, population at poverty risk, regional gross domestic product, and available hospital beds per capita. Now the impact that we studied. As you can see, we studied the impact on floods, on heat waves and health, in peri-urban fires, the impact on electricity demand for cooling, the water availability and droughts, and ozone exceedances. Now for the floods, as you can see schematically, all the indicators that we used for the impact assessment on the floods. As you can see on hazard, we use the flood hazard zone, and for exposure, we use different critical infrastructure, such as hospitals, schools, airports, highways, industrial and commercial units, and others. And for the exposure population, we use the population density and the vulnerability. As you can see here schematically, the final impact is the sum of the hazard and exposure indicators, where we have to calculate the final, we have to subtract the adaptation. For the heat waves and health, we used for the hazard indicators the number of days where humidex is higher than 38 degrees Celsius, which express the high health discomfort. For the exposure, we use population density and the social vulnerability. For the case of electricity demand for cooling, we use the number of days with CDD, the cooling degree is higher than 5, which express high energy demand for cooling. For the exposure, we use population density and social vulnerability. For the peri-urban fires, we use a number of days with high 5 danger, where FWI is higher than 30. And for the exposure, we use the slope, the aspect, and the inflammability of the flammability of the area. And finally, for the ozone exceedances, we use the number of days with ozone exceedance, and then for the exposure, we use population density and social vulnerability. For the water availability now and droughts, we use the water exploitation index and the standardized precipitation evapotranspiration index. The assessment was made at the wider river basin management level, where the main domestic water supply sources for the municipalities are located. The results refer to the municipality as a whole, since water supply is managed at the central level, may be used by the competent authorities for investigating whether there will be needed for adaptation action. For the assessment of impacts in all urban municipalities, we use different spatial databases. As you can see, we used for the climatic data the Cordex database. We used for the population density the Urban Atlas database from the Copernicus and the Johnny Research Center for the population density. We used the Corinne land cover, also used data from OpenStreetMap, as well as from the EEA, from the flood hazard zones, as well as from the Eurostat and National Statistical Service for the socioeconomic data. The resolution analysis for all urban municipalities, the presentation of the result is in grid cells of 500 meters, while for the LIFE urban project municipalities, the presentation of the result are presented at the urban block level. Now the link for the urban-proof toolkit is the tool.urbanproof.eu. I'm going to present the urban-proof toolkit online. Let me show the home. This is the home page of the urban-proof toolkit. I think that you can see my screen now. Okay.
Yes.
Okay, thank you. So you can see some information about the urban-proof toolkit. And now there are the stages where we can enter to each stage and see the information. As I said, in the stage 1, we provide information about climate indicators. Here, the information is provided only for the the project urban municipalities. You can see here that we can select the Reggio Emilia, let's say, in Italy, the maximum temperature, and the scenario. I chose the RCP 4.5, but also I can compare the 8.5. And we can see the trend from 1970 to 2100. And also all the available information is provided for everyone who needs this information. Someone can copy all this data and paste it in the spreadsheet for the extra, let's say, work. There also it's a trend line where you can see the trend of the selected indicator. That was the stage 1. In stage 2 is the impact assessment for each for each impact. Let's say I want the impact on the heat island. Sorry, the heat waves and health. Here it's 2 choices for the project municipality and for all urban municipalities. I'll choose the all urban municipalities to see the tool. As you can see here, there is a WebGIS tool where all the information provided as a layer here. We can zoom to the preferred municipality. Let's say in Greece, I can zoom in to Athens, let's say. And here I can choose the impact that I want to explore the impact, let's say assessment. I can click here in the high electricity demand for cooling. And now we can see in resolution of 500 grid, the results of the high electricity demand, the impact of the climate change on electricity demand for cooling for all urban municipalities here in Attica Prefecture. We can click on each cell and also take the information here of the impact assessment in each grid. There are also relevant climatic information. Let's say the climatic indicator that it used for the assessment. There are also information about heat waves and health for the peri-urban fires, for the floods, and also other relevant indicators, the socioeconomic indicators, the literary rate, population density, and some other social hydrological properties. there are also some tools such as the compare tool, which is very useful. In this tool, we can select on the left the indicator that we want to see. Let's say the electricity demand for cooling from the current situation, and I want to compare with the electricity demand in the future under the RCP 8.5. You can compare, and now we can compare the two layers. On the left is this indicator, on the right is the choice on the right, and we can move this red line and we can see the results. The stage 3 is the exploitation of the available adaptation options. In this stage, you can also log in, sign up to this tool, and I'll tell you about the different from the view mode to the edit mode. Let's go to the view mode because I don't have the username and password here. So in this stage, you can see the multi-criteria analysis that we conduct for the assessment of every adaptation measure that we found and is suitable for this for the urban areas. As you can see here, someone can edit the weights. So this is the difference between the view and the edit mode. Now I can't change the weights here and are equal. And someone can choose here the impact, let's say the electricity demand for cooling, and see the available adaptation measures, and also the score that take during the MCA that we conduct during the project. The MCA was conducted from stakeholders and experts from national, local authorities, from companies, academic bodies and research institute in Italy, Cyprus and Greece. We can choose a different impact. We can see here the different adaptation options. There are also information about each adaptation option. And if someone was in edit mode, all these scores will able to change all these numbers, and so construct their adaptation strategy in stage 4. As you can, I can enter in this stage 4 and see the prioritization of the adaptation measures and see the score, the measure that took the higher score for each impact. So the measure that gather the highest scoring may be included in the local adaptation strategy of the municipality. And final, the stage 5 is the monitoring and the review. Here we can monitor if the adaptation measure that we plan to implement has an impact, let's say, to decrease the impact of the climate change. I will show you the stage 5 in the floods. Sorry, I have some examples here because it may has a lot of time to load. As you can see here is the stage 5 in the flood impact. I chose the Cyprus. As you can see here, we can select the country, the Cyprus, select the Cyprus, and the municipality of Strovolos. I would like to show you a real example, how we can use the tool in a real example. So we know that the municipality of Strovolos is going to implement 2 adaptation measures in the municipality. I forgot to say that, as you can see here, the municipality is separated in grids of 500 meters. You can select each grid where the adaptation measure is going to implement. We know that in this grid, in this area, Strovolos municipality is going to implement an adaptation measure. As you can see, I clicked in this grid and this line activated. This is all the information which is follow this grid. As you can see, there is information about the population density, if there is school or no, if there are hospital, if there are cultural monuments, is the industrial or commercial units, there are road network, and you can choose yes or no. Now the information is the information that we also provided from the literature. If in the future something changes, the user can change. Let's say if in this cell a school will build, maybe the user can select yes here, and the result will change. So in this grid, the municipality is going to implement adaptation measure. The area of adaptation measure is 25,000 square meters, and the adaptation intervention here is is a pavement from permeable materials on sand. This is the adaptation intervention that is going to implement here in this grid. And we can update this line, and you can see from 5, the flood impact, the new impact is 3.46. And as you can see here, the impact is decreased from this intervention. And also, another example in this grid, where in this grid, the adaptation measure, the adaptation area is 50,000 square meters, and now the adaptation intervention is urban gardens. So the municipality will build urban garden in this grid. We can update the line, and you can see that the flood impact from 5 will goes to 3.92, and you can see from the red, let's say the high impact, now the grid is on the medium to high impact. So this map, maybe the municipality can extract this map and attach to the report, let's say. The same is from the other impacts. Let's say from the health impact, I choose here the municipality of Lefkosia. As you can see here, the lines, we have to provide information about the adaptation area in square meters, and also the mean summer humidex after the intervention. We have to add this number here. From the electricity demand of cooling, the example of municipality of Egaleo, we can add here the base indoor temperature, let's say 20, and the indoor temperature after the intervention, let's say 20, and we can update this line here to see the difference of this adaptation measure in this grid. And finally, in peri-urban file, we can insert information about the slope, the aspect, about the Corinne land use. As you can see here, this selected grid is a coniferous forest, and we have to add the FWI after the intervention. You can update this line. You can see if this intervention will change the impact of the climate change in this specific grid area. So the potential end user of the urban proof toolkit are the municipalities, the environmental consultancy companies, competent regional and national departments, environmental technology companies, assurance companies, organizations and initiatives dealing with climate change adaptation, researchers, students, and all citizens. Thank you for your attention. My name is J. Lemesios, noa.gr if you want further information about the urban proof toolkit and how you can use it. I forgot to say that in the site here, there are also the methodology and the user manual, as well as demonstration video for someone who wants to explore more about the urban proof toolkit and how to use it, for the user manual and demonstration video. That's for me. Thank you for your attention. I don't know if you can hear me.
Yanis, it was interesting.
Thank you.
Of course, there will be questions, I hope. So is there any from the audience?
Me, I have a question.
Okay.
Yes, and it is how could we implement and use your tool in other countries, for example, here in Spain?
So, sorry, I didn't understand you.
Yes. How?
Friend, a little louder.
Okay, now better?
Yes.
Okay, yes. How could we implement and use your tool in other countries like Spain?
Now it's not provided for other countries except from Italy, Greece, and Cyprus. Maybe we can expand this tool during another project. Hopefully, we'd like to expand this tool in other countries, but we need extra, yes, say another project, let's say.
Okay, that's an interesting idea.
Yes, but everyone can use the methodology if they want to expand this in other area. Not, let's say, construct a tool, but use the methodology and assess the impact of these impacts in their area. All the information are provided in the deliverables, which are available on the urban proof website.
Okay.
Okay. Thank you, Fran.
Thank you. Any more questions? If not, I will make one.
Okay.
Actually, it's similar to France. I think it's well. The question is how you plan to exploit this tool in the future. This is first question. You know, it's a lot of work behind. A tool is highly relevant for me.
Yes.
And can be used by all those stakeholders if available, and in many countries, as said by Fran.
Yes.
So what are your plans in this regard?
For now and for the next years, we plan to expand the urban proof toolkit on the urban municipalities of the 3 countries. There are many urban municipalities, as I said, more than 3,000 municipalities in these 3 countries. So from the next, let's say, afterlife activities are the introduction of this toolkit in all these urban municipalities. After that, or in parallel, I don't know if we have the financial, let's say, help for this to expand this tool in other countries. This is difficult now. We focus now on the urban municipalities of the 3 countries. But everyone can use the methodology, as I said. If you need more information, we can provide you all the available, let's say, methodology.
Okay, thank you.
Okay.
I asked this question on purpose because we've been involved in many European projects, and as you know, there are always deliverables and results, outcomes, which are there until the end of the project, and then actually there is no, let's say, commercial exploitation of that kind of tool or outcomes.
Yes.
And this is let's say a bad side of European projects, as many times there is no, let's say, businesses behind to see the business type of opportunity for this, let's say, in this case, this tool.
Now many urban municipalities have expressed their interest to use this toolkit. We hope more municipalities use, because as you said, this is a toolkit for, we construct this toolkit for the use, not for, let's say, construct another toolkit.
Yeah, okay. What we, just to say how we see that, we actually initiated the International Circular Construction Cluster. And one of the reasons was that we would like to have an ecosystem, international one, on international scale, where partners can, after the project, also work together on exploitation on the results of these 3 life projects, actually. You know, I'm pretty sure that there should be, you know, some continuation of co-working, collaboration, enabled to bring to these municipalities something valuable and affordable and usable. And this is not, you know, a simple task. As you said, yeah, there should be another project. Yes. So we have to raise funding for that. And if there is not a project, maybe there is some other approach to get this funding and make this as a business or service, common service of group of partners within that project. And this kind of international network or cluster can be a field where this is prepared, coordinated, and somehow put forward, forward. So if this is of interest of you, we can talk in this regard, and it's the same for Heatland. You know, it brings to the sustainability of the environment a lot. So why not to expand this technology to other markets and make benefit for your partners, our members in our case, in business terms? And I think this is very important.
Okay, it would be great to be part of this cluster. Yes.
Okay, so let's keep in touch in this regard.
Yes, of course.
Fran, I think we are slowly coming to the end of today's workshop. I'm still asking or inviting other attendees to make questions, to join the discussion, have some ideas or comments about all 3 presentations? Please go ahead.
Maybe not.
Not.
I think no one.
No.
No one. They're happy with that. Actually, it was very interesting, as I said at the beginning. All those works which were done, I think there should be something after the end of the project. That's my personal point, because Heatland is finishing. Your project has finished just right now, just in the middle of the year. I think also the project presented by Stavros was going to end. So let's think what after the end of the project. That's my message to you all and to us all, because I'm also part of the Heatland project. What to do, how to exploit that work we all done. You know, it's quite some work, especially in this long urban roof project, and it's great work. I see the tool is working well, and I think it's needed for designers, for planners, for many stakeholders involved in urban design, building design. So it should be there at hand to be used on daily basis. So thank you very much again for your presentation. And thank you and Lorena, thank you for the presentation. Let's keep in touch, and hopefully they will follow up of all those 3 points.
Thank you.
Thank
you for
Thank
now.
you.
Bye bye.
See you.
Bye.
Bye-bye.
Bye bye.